So as we see in this figure, this is a system of discrete particles or system of particles. So there are four particles having so with respect to a certain coordinate system, they are having coordinates x1, x2, x3 and x4 as shown in the figure. So what will be the coordinate of the center of mass of the system? Say look at the x coordinate only. So xcm we can write like this: m1 plus m2 plus m3 plus m4. Here we have considered four particles, multiplied by xcm is equal to m1 x1 plus m2 x3 sorry m2 x2 plus m3 x3 plus m4 x4. So they are somewhere around there. The center of mass may lie somewhere around there. Now instead of having these discrete particles, if we have bodies, say this is an extended body of mass m1, and say this is one more extended body of mass m2, and say let's settle down with 3, and this is another extended body of mass m3, like this. So say with respect to a certain coordinate system, origin here. Now how to find out center of mass of such a system? Here you know that so here you have to locate the respective center of mass of these bodies. Say suppose C1, C2 and C3 are center of mass of the bodies M1, M2 and M3. Say C1 is the center of mass of body of mass M1, C2 center of mass of body of mass M2, and similarly C3 is center of mass of body of mass M3. Now here suppose with respect to this coordinate system, so this is having say x1 distances or coordinates x1, x2 and x3 for their respective center of masses. Then also we can write coordinate of center of mass of the system of these three bodies like this: m1 plus m2 plus m3 multiplied by xcm. Here it's of three bodies, so m1 x1 plus m2 x2 plus m3 x3, like that. If you differentiate the equation, you get velocity and acceleration like that. So m1 plus m2 plus m3 multiplied by vcm equal to m1 v1 plus m2 v2 plus m3 v3. See, in this situation, say at a certain time the coordinates of the center of masses actually of the bodies m1, m2 and m3 are x1, x2 and x3 as shown in the figure. Now after a certain time coordinates of m1, m2 and m3 change to say x1 prime, x2 prime and x3 prime respectively. So here this is delta x1, so we write delta x1 is x1 prime minus x1. Similarly delta x2 equal to x2 prime minus x2, and similarly delta x3 equal to x3 prime minus x3. So this is actually delta x1. So delta x1, delta x2 and delta x3 are the change or the shift, the shift of m1. Now delta x2 is shift of m2. Shift means the change in coordinate. shift of m3. Say we all take all the shifts towards the right because this is the x-axis. X-axis we have chosen towards the right, so that is the positive direction, right? Now, so at a later time, let us draw these bodies. Say m1 shifts here, m2 shifts here, and say m3 shifts here. So x1 prime, this is x1 prime, x2 prime, and x3 prime. Here it is, I'll draw it below. So this is x3 prime rather. So the shift, so that is the, so the shift is this delta x1, right? And the shift of m2 is delta x2 to the right. By convention we take the shift towards the right. It may come out to be negative. So if delta x is negative, that means the body shifts towards the left, so along the negative direction of x-axis. So now suppose the center of mass of the system was somewhere, say somewhere it was there, so the center of mass also shifts in this way. So this is delta xcm, delta xcm. So what is delta xcm? Is shift of the center of mass. That is the final minus the initial right, that final coordinate of cm minus the initial coordinate of cm. So as you see in this figure, the initial coordinate of the cm this, and the final coordinate of the cm is this. See, highlighting this points. So what will be delta xcm? Now as we know, this m1 plus m2 plus m3 into xcm, say initial xcm initial, I for the initial state. So final coordinate of cm, I write xcm f, and initial coordinate of cm xcm I. So from this origin, this distance of this point, so I can show here, this is xcm I for initial, and this will be xcm f. xcm f for the final coordinate of the cm. So that is equal to m1 x1 plus m2 x2 plus m3 x3, and also see in this situation. Okay, so here also let's get back to it. So now m1 plus m2 plus m3 into this xcm final is equal to m1 x1 prime plus m2 x2 prime plus m3 x3 prime. So if you subtract, say name this equation 1 and this one equation 2, so 2 minus 1, what will you get? So that is m1 plus m2 plus m3 into delta xcm is equal to m1 delta x1 plus m2 delta x2 plus m3 delta x3. So this is some format, this is some equation we have got, and we will make use of this equation. So we'll take up a problem and explain the concept what we have learned. So problem is that a man of say mass small m stands on the left end of a boat of mass capital M and length L. Now the system was at rest. System was at rest. I mean, both the boat and the man were at rest. Now find the distance by which the boat shifts if the man walks to the right end of the boat. So the length of the boat is equal to L. So this is given. This length is equal to L. So that is the question. Now how to solve it? Say. So we'll begin the solution here. No, one more thing is given. Neglect friction. Neglect friction between boat and water. I mean, it is as good as a frictionless horizontal surface. Now we have to find the shift of the boat. Let the boat shift by. So we'll begin our solution here. So let the boat shift by say S, shift by S. By default, let us assume shift by S to the right, because you know these all we will deal with all this with the coordinate format. So this is the initial position, this is the person, and later on the boat, suppose the boat shifts by S. So here we have assumed that the boat shifts by S. So this is S actually, right? So this is these are the conditions. So initial position and this lower one we have drawn is the final position. Now we have to choose in a certain problem the x equal to 0. Suppose this is the x equal to 0 we choose, and as we know we'll apply that formula. So let say m1 is equal to m and m2 is equal to capital M. Now we will use this formula, m1 delta x1 plus m2 delta x2 will be equal to m1 plus m2 into delta xcm. Here what will be delta xcm? Here delta xcm will be equal to 0, because the center of mass does not shift. Why it does not shift? Because velocity of the center of mass was 0 initially. So why will it shift actually? Because there is no external force on the system. When the man walks on the boat, man will apply force on the boat. Due to that, so that is basically friction force. Due to that, the boat will move towards left and the man will move towards right. We have assumed it to the right, but we are expecting a negative answer for S. So whatever forces are internal forces, there is no net external force. No one is pushing the system of the man and the boat. So VCM was 0 because the whole system was at rest. So V1 0, V2 0. So that means VCM is equal to 0. So here delta XCM is also equal to 0. Right? That is the most important point here, that the center of mass does not shift. Okay. So what is delta x1? Delta x1, what is the final coordinate of the man? So this is the length of the boat L. So final coordinate is L plus S. The initial coordinate of the man was 0 as per our choice of x equal to 0. Right. Now what is delta x2? Delta x2 is the shift of the boat, and we have assumed that the boat shift by s. Right. So let's put the values like this: m multiplied by, so m1 delta x1, that we are doing. So m1 is small m into L plus s minus 0 plus m2 capital M into s is equal to 0. So what does it imply? Implies s is equal to minus ml by m plus n. Implies, so it come out to be negative. So implies that the boat shifts to the left by how much distance? ml by small m plus capital M. So in this problem it's actually the same. So a boat, so initially A of mass say 2m, B of mass 3m, and the boat of mass, say make it 4m, boat of, so A is a person, B is a person, and they are standing on a boat of mass 4m, all were at rest. Now find the distance by which the boat shifts if A and B walk towards each other and meet at the midpoint of the boat. Or meet at the center of the boat rather. So again you have to assume that no friction. So assume no friction between boat and water. So let's quickly make a diagram. Now before solution we have to assume let the boat shift by s. Obviously we will choose towards the right by default, because we shall consider the x-axis towards the right. See, you can choose towards left also, that's your choice, but I always choose x-axis towards the right. So this is A and B. This x equal to 0 I will choose here. Origin of the coordinate system x equal to 0. Now this is so this was the situation. Now in the final condition the boat shifts by S from here. Let's draw this line. See, if the diagram is proper, the problem will be solved. The neat and clean diagram, you can see everything happening. A and B, say they meet at the midpoint of the boat. Now, here it is given that the length of the boat is L, right? Length of the boat is L. So that is L by 2. This distance L by 2, and we have also assumed that the boat shifts by a distance S, and that too obviously by default towards the right. Okay, now simple thing, that's that simple equation. So mass of A times delta x A, that means just shift, plus mass of B times delta x B plus mass of boat times delta x boat. So we'll write directly S, delta x boat is S, we have assumed, is equal to 0. Here it will be 0 because the center of mass of the system of the two persons and the boat, they will not shift because they were at rest. System was at rest before. And remember always that what is delta x? Difference between the coordinates, right? So MA, so delta x is equal to, for anything, x final minus x initial. Okay, so what is MA equal to? MA is equal to, as given, 2m, right? So 2m multiplied by delta xa, the final coordinate, so the initial condition of the system and the final condition of the system. So S plus L by 2, right? S plus L by 2 minus, what was the coordinate? It was 0, plus MB means 3m times final coordinate S plus L by 2 obviously, minus the initial coordinate of B was L, right? It was at the right end of the boat, plus mass of the boat 4m into S is equal to 0. So let's simplify this. So get 2S plus L plus 3. We will remove those m's, right? So 3s, so that is L by 2 minus L, so minus L by 2, so minus 3L by 2 plus 4s is equal to 0. So 2 plus 3 5 plus 4 9s. 9s is equal to 3L. So so it's 3L by 2 minus L, right? So 9 times S is equal to L by 2. So S is equal to L by 18. So one more problem. Block of mass capital M with semicircular track of radius r as shown in the figure rests on the smooth horizontal surface. A uniform cylinder of mass small m and radius r is released from the position shown in the figure. How far has the block moved when the cylinder reaches the bottom of the track? So again we'll work with the same coordinate system type approach. Now we can assume that let the block let the block move by s by default to the right, because the x coordinate I will choose will be towards the right. So let us draw a figure below and the final position. This is the cylinder. This one is a cylinder then, right? Final position of the cylinder having radius r. So as we have assumed that the block shifts by x, so from here shifts by s rather. Yes, so this distance in the diagram is s. Now we have to choose a coordinate system x equal to 0. So let's choose this as x equal to 0, no problem in it. Whichever point you choose x equal to 0, that is, so the answer won't depend on that, right? Whatever shift will happen does not depend on my choice of coordinate system actually. So let this little thickness be h, and so this is r radius. So what about this distance? This is the track radius is capital R, and this little thickness is h, as we have assumed. It won't matter, right? It won't matter. So what is the final coordinate? Final as per the chosen coordinate system, final coordinate of the cylinder is equal to this, and the initial coordinate of the cylinder. Then we can find out the delta x for the cylinder. So final coordinate of the cylinder, as you see here, it is s plus h plus r rather. The initial coordinate of the cylinder is how much? So from this x equal to 0 till this distance is h plus r, h plus small r rather, right? So this delta x for the cylinder, say C, you name this cylinder as C and the block as B. So delta xc, C for the cylinder, is equal to change in the coordinates. So s plus h plus r minus of h plus r. So that is s plus capital R minus small r. So that is delta x for the cylinder. And now delta x for the block, what is that? We have assumed delta x for the block to be s. We have assumed that the block shifts by s. So therefore we will apply that in see, again the center of mass is at rest because system was at rest. So as delta x cm is equal to 0, delta x cm, right? We are talking about x coordinate because see the net force delta x cm equal to 0 because the system is at rest, and also the net force along the x axis is equal to 0. We are not saying that the net force is 0, no, there is gravity, but gravity is acting in the downward direction or the y axis. So we are concerned with the x coordinate of center of mass and the block and the cylinder, right? So delta xcm equal to 0 implies uh, mass of the cylinder m multiplied by shift s plus r minus small r plus mass of the block capital M multiplied by s is equal to 0 implies uh, small m plus capital M s is equal to minus m times small r minus capital R, implies s is equal to minus m small m capital R minus small r divided by m plus capital M. So what does so that means the block shifts by distance this m r minus small r by small m plus capital M towards the left. Because of this negative sign, it shows that the block shifts towards the left. One more problem, a block of mass small m 5 kg is placed on smooth wedge of mass capital M 30 kg. Determine the system is released from rest from the position shown in figure. Determine the distance the wedge moves when the block reaches the bottom. Neglect size of the block. There is no friction between ground and the wedge. Given L is equal to 0.5 meter. Here velocity of center of mass, the x component of velocity of center of mass is 0. And also the x coordinate of center of mass does not change. Why it does not change? Because the net force, so the net external force along x-axis, that is the horizontal direction, is equal to 0. And also the system was at rest, so there is no question of having VCM in the x-axis. So now let the wedge shift by s by default to the right. Now let's have this the initial state and the final state drawing below. Now let the wedge shift by s. So we have to choose a 0 here. So let's take this line as 0. That is x equal to 0. Now the wedge shift by s. Now what is the coordinate of the block? Final coordinate of the block and the initial coordinate of the block. So initial coordinate of the block, as you see, is L, length of the wedge. So delta x for the block is equal to s minus L. Now delta x for the wedge is obviously s because the wedge shift by s to the right. Now simply we can do that, right? That formula, m1 delta x1 plus m2 delta x2 is m1 plus m2 delta xcm, and here again delta xcm will be equal to 0. So m11 for block, so small m multiplied by s minus L plus capital M multiplied by s is equal to 0. So therefore we get s is equal to ml divided by m plus capital M. In this case, the weight shift towards the right.